So let's take a look at this equilibrium problem. It has this is actually a solubility of silver chloride, and usually these are written the other way. So just that I don't write out the equilibrium constant and then have to convert it by inverting it. Like we learned this, like k nu would be k old if you have to reverse it over one or under one. I mean, so to avoid all that nonsense, I'm gonna write it the way these are usually written. So I'm gonna write it with AgCl on the left, and the equilibrium arrow is going like this. And so this is showing the process of it dissolving silver chloride. And they don't bring the equilibrium value into this, but you could easily find this in your appendix. The KSP for this is 1.8 times 10 to the negative 10th. So, and then let's try to answer these questions. So, what that means is, so if you set up an ice table, we're going to try to answer these questions. I think it's a little easier if we have some numbers to work with. So solids, you just kind of dash them out. But as we'll see, I'm going to point out that what they say here is, well, what if we change the amount of solid, right? So and you first might think like it doesn't matter at all, but these things come from, the two ions came from the solid. So, all right, so let's try to answer some of these questions. So what this means is these would be zeros initially. This goes up by x, this goes up by x. And at equilibrium, these amounts would be x and x. So you could easily solve for this. KSP is the concentration of product over reactant. And the two products are these two ions. So, and we have the value here. And since we know that they're both x, it's just x times x. So if you solve for x, you square root, this would equal 1.8 times 10 to the negative 10th. So solving for x, we just square root both sides and we get this. X is 1.3 times 10 to the negative 5th moles per liter. So moles of each ion. So moles of Ag plus and 1.3 times 10 to the negative 5th moles of Cl minus. So what does that mean? So we could, if you add, let's look at each one of these. So Ag and Cl will both increase if you add solid. So let's say we had 1 gram of this, 1 gram of AgCl, and now we up it to 2 grams. What would happen to these equilibrium amounts? The answer is nothing. So why is it nothing? Because it's already at equilibrium when it has this much moles of AgCl. So it says it's already at equilibrium. So you added enough to cause it to dissolve by this much. And then they're saying you're going to add more. What would happen? Nothing. Okay, so you'd have like, it look like this. You have a beaker, there's water, and then there's a clunk of AgCl, some solid AgCl. Okay, and this has already, it has already made all the ions it's going to make. That's what they told you. They said it's at equilibrium. Okay, so it's already made all the ions it's going to make, this many of each one. And now they're saying, okay, let's add more. Let's add a bigger clunk in there, right? So what's going to happen to the amount of Ag and Cl? Nothing. You just add more junk to the bottom of the beaker. So your Ag and Cl will be the same. Okay, so how much solid does it take to get this much if you have a 1 liter container? So if you have a 1 liter container, how much of, let's say, 5 grams AgCl would dissolve to reach equilibrium? Okay, so we know that this is the equilibrium amount. So all this really is saying how much of the AgCl, and this is the equilibrium amount. So there, if you look at it, you could just change you're just changing substance. The stoichiometry question is what this is. Okay, so if you have 1 liter, how much AgCl dissolves? How much of this would dissolve if you had a 1 liter container? So you could just start with this, and then you convert it to stoichiometrically to AgCl. So even though this is not part of the equilibrium, right? We just showed that if you added more of it, it's not going to increase the amount of ions. So if you have a 1 liter container, what's going to happen? So you just take the 1.3 times 10 to the negative fifth moles, and you could choose either Ag plus or Cl minus. So we'll just use the Ag. Okay, if you have a 1 liter container, so we're gonna change. We're basically, it's a stoichiometry question, and we're gonna try to. What we're looking for is how much mass of AgCl would dissolve here. Okay, starting with molarity, and they gave us the size of the container, 1 liter. So we're gonna cancel out the 1 liter. Next, we're gonna use the mole to mole ratio. So it's 1 mole of Ag for every 1 mole AgCl. So 1 mole of AgCl dissolves for every 1 mole of Ag. Next, so that cancels with this. So next, so again, we're getting grams of AgCl, so we need the molar mass of AgCl. So I plugged this into my molar mass app earlier, 143.3 grams per mole. And if you calculate this, we get 0.0019 grams of AgCl. So out of this 5 grams that we had, only this much needs to dissolve to already reach equilibrium. So what does all this mean? It means that its KSP is so low that essentially you wouldn't even see this happen. That's so little compared to the 5 grams. You wouldn't really see if you did this in real life. Like if you actually added 5 grams to 1 liter of solution, you wouldn't even see anything disappear. Because if you subtract it, it's like negligible compared to the 5 grams. So there's an interesting thing here. Now, what if I wanted to mention? So what if you change this? And this is Q. This is what happens when you mess around with the reaction quotient. What if you change this to 2 liters? Do you see that? So if you change the size of the container instead of 1 liter, so instead of 1 liter, what if you double the size of the container? Then what happens? Okay, so you change the size of the container, the amount of solvent you have. So 1 liter to 2 liters now. So if you look at the math, it would actually double the amount of solid that has to dissolve. But what happens to the concentration? It would be the same. You're plugging in the same number here. How much of the solid would actually dissolve? Double, because you'd be plugging in a 2 here instead of a 1. So that's the thing. That's the thing with that's Le Chatelier's principle. So if you make the volume bigger, it needs to fill this space in. So these are like these little dots of Ag and Cl. So if you double the space, you're going to need double the dots to achieve the same concentration to reach equilibrium. So if you remove this and put it in more volume, you'll actually get more of this, the AgCl, to dissolve. So let's go through the other answer choices. So we have a B, Ag and Cl will both decrease, no. So Ag and Cl will both increase, no. AgCl will increase and this will decrease, no. So the only correct answer is this one, E. They do not change. Even if you double the container, it still does not change. You'll get more moles of solute, but the concentration would not change. This would also be correct. Okay, so I hope you found this video useful.